will be discussing about chapter 2 of class 10, that is of acid, base, and salts. So without any further delay, I think we should start. So here are some notes before. This is the name of the chapter, that is acid, base, and salts. Before the start of the chapter, moving on towards what are acids, bases, and salts, we will discuss some theories about acids and bases of various scientists. And at the end of the chapter, we'll be discussing about the salts. But before moving on towards the theories, we should know about some basic properties of acid and bases. So let's move on towards that. Acids have sour taste, for example, unripe fruits, or the example is lemon juice. Or on the contrary, bases have the bitter taste and they feel slippery to touch, like soap. They turn blue litmus to red. This is the property of acid. Litmus is basically a solution or a litmus paper. Whenever we dip blue litmus paper into the acidic solution, it will turn into red. And if it is if it has the property of red, if it is, we can say that this litmus paper is already red, then there will be no effect on that litmus paper, because property of an acid is that to turn the litmus into red solution, red color. But if it is already red, then there will be no effect. And same goes for the bases, but on the very opposite, that bases turns red litmus to blue. And if it is already blue, then there will be no effect. It remains the same. The colors remains the same. They are corrosive in concentrated form. What do you mean by the term corrosive? That they corrode metals. We have already discussed this in the 7th chapter of class 9. In the concentrated form, like, they're very corrosive in nature. And the concentrated form, you should also know about that. There is a relatively higher amount of solute in that solution, in that form, other than to the solvent. So that is what the concentrated form is. You have already discussed. You have also discussed this in your 9th class, chapter 6 of solutions. On the contrary, if we talk about base, the bases are non-corrosive except for the concentrated form of NaOH and KOH. These two bases are corrosive in nature, and the rest of the bases are non-corrosive. The last and the final properties of the acids and bases are that their aqueous solution can conduct electricity. Both acids and bases can conduct electricity because in their aqueous solution. Why? Because electricity is flow of charges or flow of ions. And whenever we dip an acid or a base into a solution, it will turn itself into ions. So we can say that the acids and bases, aqueous solution of acids and bases can conduct electricity. Let's move on towards the next topic, that is of the first theory relating to acid and bases concept. The first one is the Arrhenius acid base. This was the first scientist who gave the basic framework for the identification of what is an acid and what is a base. In 1887, a scientist gave his concept. His name was Arrhenius. According to Arrhenius, a substance which upon dissociation gives a hydrogen ion is an acid, as you can see here. As I have written over here in the journal reaction, that HA, suppose this is a basic or a journal acid, we have dissociated this acid into water and it will turn into H plus and A negative. If a substance is giving an H plus ion, so we can say that this substance is an acid. As I have given you some examples, like you can just wait, let me just scroll down. As you can see that I have given you 3 examples of acids. As you can see that there is the first example of HCl. Whenever we are dissociating HCl into water, it gives us H plus and Cl negative. If we talk about HNO3, it gives us H plus and NO3. This H plus is basically denoting that HCl is an acid, HNO3 is an acid. And if we talk about acetic acid, that is CH3COOH, whenever we dissociate it into the water, as we know that this is a weak acid, it will dissociate into its ions at a very slow rate. But still, we will consider this as an acid because the substance is still giving us H plus ions in the solution. So we can say that CH3COOH is an acid, but it is a weak acid as compared to HNO3 and HCl. On the very opposite, if we talk about base, as Arrhenius said that the base is a substance which on dissociation gives us the hydroxyl ions in the aqueous solution. the very important point is the Arrhenius acid-base concept only lies between the aqueous solution. Okay? If there is no aqueous solution, Arrhenius acid-base concept will not be applicable to those substances, those conditions. So for a general reaction, you can see that BOH is a general base, and we have dissociated this base into water. It gives us B positive and OH negative. Now this OH negative shows that BOH is a base. Let's just talk about some examples of the bases which are discussed in your book. First one is NaOH. As you can see, I have dissociated NaOH into water, and it gives us Na positive ions and OH negative ions. Now this OH negative ions represents that NaOH is a base. KOH, again, you can see that upon dissociation gives us OH negative. That is why it is a base. And again, the last calcium hydroxide, it is giving us the 2 hydroxyl ions upon dissociation, so it is also a base. So if we summarize the Arrhenius acid-base concept, it basically shows us that acid is a substance which upon dissociation gives the hydrogen ion, and base is a substance which upon dissociation gives the hydroxyl ion. Let's just discuss some of the limitations or some of the flaws in the Arrhenius concept. But although this concept has some flaws, but this scientist, Arrhenius, has provided the basic framework for the upcoming scientists to move on their studies, to study further and further. But there are some limitations. We are going to discuss about that, and these limitations are, there are 2 limitations. First one is we have already discussed during the lesson, that this concept is only applicable in the aqueous medium. If there is no aqueous medium, you cannot differentiate between acid and the bases. And the second one is, this concept only tells us about the acid and bases if the substance is giving us H plus ions and the substance is giving us OH negative ions respectively. The substance which is giving us the H positive ions will be termed as acid, and the substance which is giving us OH negative ions will be termed as a base. It does not explain the nature of the compounds like CO2 and NH3. As you can see, in CO2 there is no H plus ion, so still CO2, but still CO2 is an acid. But according to Arrhenius concept, you cannot describe this CO2 as an acid. And if we talk about NH3, there is no OH negative ions present in the NH3 compound or a molecule, but still it is a base. But if you talk about the Arrhenius concept, you cannot be able to describe NH3 as a base. So here are the 2 limitations that Arrhenius concept has in his concept. So that's all for today. I hope there will be no issues. This is a very easy and peasy topic, you can say that. If you have any questions, you can ask me in the comment section. That's it from now. Till then, it's okay. Bye bye. Allah Hafiz.